video, I'll show you how to use Emaris to analyze and categorization of pre-synapse and post-synapse. Here I have two groups of photos I got from Confocal. Those immunostaining samples from the induction mm, by Yi-Qing. So here I have two groups, one group of MJP and one group of TGS2, they all are 2DVF. So firstly, we need to create a folder we call assay, which is this folder. Under the folder, we need to input your image folder, which is we need to create two image folder of MJP and TGS2. Here I already input my confocal images to Emaris, so you will see four pictures and four scans in MJP group and four scan in TGS2 group. Before I start this protocol, I want to mention some really important points. So for the confocal scan, whatever you adjust the z-stack, but when you scan all of your fish, all of your sample, you should keep the same setup, like percentage of voltage, or especially each channel. You should keep all the setup for all of those samples, because if you change uh, some of the setting, the strength of the fluorescent are different. So you need to keep all of your fish, they are taken and they are scanned by the same setup. The only adjusted part is just the uh, Z-stack, because yeah, try to like mount your fish close to the bottom uh, to the bottom part of the confocal well. And uh, besides that, I want to say it's better to remove the head. If you do like just like a middle part of body, you can remove the head and the yolk, because the head and the yolk, they are uh, so thick, so it's hard to make the especially the trunk part too close to the bottom part, so it will um, reduce the fluorescence signal and make the D stacks thicker than what you want. So if you can cut, especially for uh, this confocal scan, it's better to remove the yolk and cut the head. Just only keep the middle part of body. So it will give you very uh, unified scanning. So okay, so let's start it. In group of MJP, I already analyzed three scans. So I will start this protocol from this fourth scan. Okay. Once you finish analyze, you need to save your file in a project file, not only a picture or something like that. So you will see they're different. So once you finish analyzing, you have this kind of small icons here, which means you create a project file for all of your modification and your analysis in this file. So once you close this software and you will open it, you still can see this kind of project file there. So always save project file, not only a picture. Okay. Okay, let's click this one. So here you can see a 3D scanning this middle part of track. So here I use 40 times of lens to image my fish. So you only see a small part of fish can be imaged in my couple scan. Yeah, 40 times can give you more detail, so you can see more like this kind of red dot. Actually, the red dot is green, so we need to. I don't know why, because we use the second. I mean, the antibody, which is 4AA. I mean, for I'm not sure what kind of secondary I use, but they are different. So the color is kind of reversed. So we need to change channel 1, which is, should be the green channel, green color. So you can change it. So we need to change channel to the red color, which is pre-synapse. So the axon part. This is now is correct. So actually, you already can see some yellow color, which means pre-synapse colocalized with post-synapse. Because red and when red overlap with green is yellow color. So how we analyze this kind of colocalization? So first thing first, we need to remove some background. Uh, Here I I will adjust the background of channel 1, which is post synapse, which is green color. So you need to click. So you will see when you click them, it will choose the one you want to adjust. So when we click channel 1, you will see some minimum background is 0, maximum is 460. So for all of my images scan, I use the same setting for remove the background, which is let me check. Uh, I use the minimum 200 for for the green channel, which is post synapse. So I remove once I type 200 for minimum, it will can help me remove those kind of background, make only post synapse clear and like a green dot. Then we need to adjust the pre-synapse, which is the red color. You will see some like very fade red color, which is the background. So we need to remove the background. So I would do another setup, which is give a minimum of course, you need to uh, know, please, before you adjust the background, you need to click that channel. One, if you don't click that channel, you won't change anything. So we click channel 2, which is red color. We give a minimum 100. This is my setting. It depends. You can change it uh, until you can see a clear background. Okay. So now you will see the background getting better. We can see after we give a minimum 100, we see background which disappeared. Okay, now what we need to do is go for yeah, we steer in channel 2. For the channel 2, it's like an axon because they are from motor neuron. So that's why you saw the picture here is like a axon. Okay. So because of the confocal, it's not a light shift, so you have only a further part. The signal usually weaker, but here we can exclude it. So we just analyze the stronger part. So how we do that, we just like adjust the box of the picture to wrap the strong signal part. So firstly, I just care about the axon part. So I just want to analyze the axon part, pre-synapse colocalized with post-synapse of muscle with muscle. Okay. So here we click volume here, then you will see some a small function here. This one we choose should be this one, free volume, a new surface, because axons they are connect to each other, so it's like a column. So we need to construct uh, mm, the surface of axon. So we click here. You can see algorithm settings, segment only or region of interest. Because of the spinal cord, I don't want to analyze it because it's very strong, and usually for this one we just care about curious about the axon part. So I was put a box just wrap the axon part. So we take out the segment only or region of interest and we move to next step. So you will see this kind of box. So on the right side we click uh, pointer, which is select. Select enable us to edit the size of the box. If you just put like navigate, it won't change anything. Navigate only enable us to adjust the X, Y, Z position, but not allowed to adjust the size of the box. So we need to click select, then you uh, yeah, click select. We can make it smaller so we can see all of those arrow here. By clicking arrow, you can adjust the size of the box. Okay, so because I just curious about the axon part, so I will put my upper border to the axon part. It can a little bit include some of the spinal cord part. It's fine because here I want to mention something. When you do confocal imaging, try to put your spinal cord parallel with your bottom line, because this is really important. Uh, it will help you set up this box for only atom part will be accurate. So give you more accurate data later. So try to adjust your image in your confocal scan. Put the spinal cord parallel with your bottom part. Then we need to adjust the bottom part of border. We adjust the border just on the axon. Okay, so we do all of those things the same adjust. But we also don't want to exclude because uh, fish has two same side. As I mentioned, the weaker side because the fluorescence signal were weak. If you use slide sheet, maybe you can analyze both sides. But this one, I just want to analyze one side. So we adjust box to put the box to just close to this side. So that's why when you mount your fish, also try to make your fish body close to the bottom and parallel with your confocal well bottom. Okay, once you got set up this box, then you click. Oh, You also need to write down the XYZ box, I mean XY value and the size, because later we will do the setup box for post synapse. We use the same size of box for post synapse staining. Here we need to record the XYZ minimum max. We want y is 2048 and the size 2048, and the y is 702, 1276, and 775, and 1111, 34, 24. Okay, then we can click move to the next stage. So you will see here, uh, is channel 1? No, of course not. We are not doing surface for channel 1. Channel 1 is post sign-up. We are constructing channel 2, which is post pre-sign-up axon part. Okay, then we click that. We click move to the next part. So you will see some gray color inside, which means the software start to construct the surface of axon. Here I use the same setting for that, which means this what kind of fluorescence threshold should be constructed uh, for constructing axon. I use a set of a minimum threshold, which is 100. Okay, now you will see all of those selection has been, I mean, axon has been uh, transferred transferred to surface of axon. Use your eye to double check is correct. Usually, if you see something missing, you can just adjust uh, this part to make it bigger or smaller to cover all of those axons. Then we move to the next stage. Wait for the progress bar finish. If you have a GPU, usually this kind of analysis are really fast. If you use CPU, it depends how good your CPU. Might very slow, might be very slow. Okay, then if you're happy with that, just finish. You click this one, finish, execute all creation steps, and terminal this wizard. Okay, we click this one. Then we will get, you can not remove, I mean hide the volume, just show the surface, which is the surface of axon we created. So you will see. Okay, then we go to volume, then change our channel to channel 1 and hide channel 2 and hide the surface. Uh, in volume, we need to show channel 1, which is post synapse. So there are green fluorescent dot as from the muscle, So here so for axon we create surface, but for post synapse we create spot. Okay, it's different surface and spot. If your fluorescent is like a big area, like the brain, like the axon, you should create surface. If your fluorescent one small, very small dot, fluorescent dot, you should create spot. So for this one, of course, we create spot for them. So we click this one, which is here. So we create the spot. It sends us a surface we created. We need to segment only the region we are interested. We are not creating the whole area. we don't want to include spinal cord. Okay, we just care about the axon part. That's why loss uh, loss creation. I mentioned we need to record the XY value here. So we just type what we have uh, written down in our paper or anywhere else. So one yeah, for the x we don't need change. For the y is 702, 702, and 1476 and 775 is 24 and 34. Mhm. So it's better to manage. Sometimes it doesn't work really well. So we can show the channel 2 help us to find the exact position. So as you can see here, mm, which is 20. Okay, then I'm happy with this one. So we can hide the channel 2, which pre-synapse. So once you create a box for the region you are interested, then we can uh, move to the next step. We are step 2. We move to step 3. Yeah, this is channel 1 correct. We want to create the sport for channel 1. But for this one, which is uh, so when you zoom in this area, you can see some big dot they already labeled with I mean the sport has been created by for some small dot just sign up, but they haven't been created a dot for a small dot. So we need to adjust the threshold for the size of the small dot. So here what I use uh, is 30. All of my so once we adjust 30, so all the small green dot they are included. Yeah, of course have some missing, but since we took those images under the same setting in confocal microscope, so we should keep all the setup the same. Here, same. Here, I also use the same setup and same minimum size for the post synapse. So I use 30 here. Once you found all of the code inside the box has been created, we move to the final step, which is finish. Then you will see the sport has been created. Now what we should do, we're curious about the colocalization. So click the sport you have created, then go for the image processing, find sports function, split sports into surface object, choose this one. Then Immerse will use MATLAB, I mean some programming wrote by someone else. They will use that. You also can use Fiji. So as you can see here, as Fiji, it depends. If you can write some I mean processing programming for yourself, you can use it as well. So we just wait for maybe 2 minutes. Okay. Once the colocalization analysis finish, you will see this page will disappear. Uh, then we can check how many colocalization uh, spot we can find from this analysis. We just need to click one spot inside the surface. You'll see number of object number, which is 1504. Just need to write on this number here. Uh, for the total number, you need to click this one, spot. This is colocalization spot. This is the spot. You need to click click statistic. You will see the total number of spot, which is 8,023. So here we can remove the volume. So you will see these kind of couple days. They are colocalized position between uh, pre-synapse and post-synapse. So for the surface, we can check one. So you will see those they contact with those contact with the surface of presynapse, which is the axon. Okay, like here, here, and here, here. And here. Okay, okay. That's a whole protocol how I analyze colocalization. So for let me check out